There's a crisis in the study of the cosmos. Scientists say that we're wrong about the Big Bang and the universe. This rude jolt to the astronomy community has already been dubbed the crisis in cosmology. But now, the crisis has become a thunderbolt, shocking even more scientists, as new models and calculations are punching big holes in the Big Bang theory that was thought to be gospel for decades. The contradictions are so profound, it's time to sound the alarm, because essential predictions of the Big Bang theory are increasingly contradicted by better data. As shown by many teams of researchers, data from new observations are consistent with a non-expanding universe. That means there was no Big Bang. That's correct. The real crisis in cosmology indicates that the Big Bang never happened. There's a lot to unravel. You're about to discover all the key pointers disproving the Big Bang. You might want to sit down for this. You're about to be stunned and immobile. Here's what scientists got wrong for decades about the beginning of our universe. Subir Sarkar, a professor at the University of Oxford, told the New Scientist publication that he's discovered evidence suggesting that our current understanding of cosmology is broken. In support of this crisis to cosmology are several other scientists who are all saying that we need to completely revamp our entire understanding of the universe. Not everyone, though, is on board. Sarkar was quoted saying, "We are in a very unenviable position in that most of our colleagues don't even want to hear about it. But you should be kept up to speed. Here are the catastrophic facts that devastate the study of cosmology as we know today. When it comes to light elements, predictions foresaw that any super-hot explosion throughout the universe, especially like the Big Bang, would definitely generate a certain small amount of the light element lithium and a large amount of helium. Yet, actual observations show that the older the stars, the amount of lithium observed has gotten less and less. As a matter of fact, the oldest stars radiate less than 1/10 of the predicted level. The problem is, the Big Bang theory unequivocally predicts certain amounts of light elements like lithium, helium, and deuterium. They must be produced in the explosion that is hypothesized to have started the universe. For lithium, the prediction is 400 lithium atoms for every trillion hydrogen atoms. To the bewilderment of astronomers, measurements of lithium in old stars in our galaxy don't add up. Thus, the Big Bang predictions don't align with reality. They know the stars were formed very early in the history of our galaxy because they have very tiny amounts of iron and other heavy elements that are produced by previously existing stars. But in most of these stars, the lithium abundance is only 160 lithium atoms per trillion atoms, which is vastly far below the Big Bang predictions. Peer-reviewed studies indicate that both lithium and helium observations of abundances in old stars differ from predictions by more than a dozen standard deviations. And as scientists delved deeper into experimentation and evaluation, the gap has been widening at an accelerating pace. The oldest stars have less than half the helium and less than 1/10 the lithium than predicted by Big Bang nucleosynthesis theory. The lowest lithium levels observed are less than 1% than predicted by the theory. Therefore, the evidence is consistent with no helium or lithium having been formed before the first stars in our galaxy. Equally important, the study shows that the right amounts of these light elements have been predicted by an alternative explanation, which hypothesizes that these elements were produced by stars in the earliest stages of the evolution of galaxies. This alternative explanation, led by research from astronomer Eric Lerner, known as the galactic origin of light elements, or GOAL hypothesis, shows that expectations from the first generation of stars to form in a galaxy are intermediate mass stars that are from 4 to 12 times as massive as the Sun. These stars burn hydrogen to helium in tens to a couple of 100 million years, much faster than our Sun's burn rate of 10 billion years. The helium then disperses in powerful stellar winds during the late stages of these stars' lifetimes. Cosmic rays from these early stars, colliding at high energy with other nuclei, produce deuterium and lithium, meaning the Big Bang theory predictions are certainly not conforming to cosmic predictions. It's been universally understood that since the intense radiation of the Big Bang would produce matter and antimatter in equal amounts, a mutual annulation of particle-antiparticle pairs would reduce the surviving matter density to around 10 to the negative 17th protons to centimeters cubed. The observation showed that the matter density in the universe is observed to be at least 10 to the negative 7th ions per centimeters cubed. That is more than 10 billion times higher than the Big Bang prediction. So, to align with the Big Bang prediction and fill in the unknown gap, Big Bang theorists propose there's some unknown asymmetry between matter and antimatter that would lead to more production of matter. Unfortunately, it's all speculation, as this has never been observed in laboratory experiments. Large-scale experiments have contradicted this prediction as well, with no evidence of decay at all. One might just as well call it God. According to the original predictions of the expanding universe theory of the Big Bang, an optical illusion makes objects at high redshift appear larger and dimmer, so their surface brightness, the ratio of apparent brightness to apparent area, declines sharply with redshift. The history of the subject began with the development in the 19th century of wave mechanics and the exploration of phenomena associated with the Doppler effect. The effect is named after Christian Doppler, who offered the first known physical explanation of the phenomenon in 1842. However, true real-life observations show that based on observations of thousands of galaxies, surface brightness is completely constant with distance, as expected in a universe that is not expanding. So, Big Bang advocates attempted to adjust the prediction after observation showed that the surface brightness dimming did not occur. They went on to hypothesize that galaxies were much smaller in the distant past and have grown greatly. Unfortunately, observations have contradicted this solution as well. Truth be told, there have not been enough galaxy mergers for the growth rates needed. In addition, the ultra-small galaxies hypothesized would have to have more mass in stars than total mass. This is an obvious impossibility that can't be taken lightly, pun intended. According to the original predictions guided by the Big Bang theory, the universe is supposed to start off completely smooth and homogeneous. Structure starts small and grows over time. Yet due to observations via space observatory telescopes like the Hubble that have peered farther into space and discovered huger and huger structures of galaxies, tangible details show that these massive galaxies are too large to have been formed in the time since the Big Bang. And it's not only for galaxies. The newly discovered black hole in the middle of the Milky Way galaxy also disproves the Big Bang theory. It is a supermassive black hole, or SMBH, that is way too large to have been created from dying stars. The time of its origins and its location just don't justify the predictions of the Big Bang theory. On top of that, the idea that the cosmos looks largely the same no matter where you go, which is called the cosmological principle, has been around in some form or another since the 1500s. Now, scientists like Sarkar advocate that the way our Milky Way moves through the universe could be interfering with our understanding of the rest, similarly to how our ancestors first thought the sun was rotating around the Earth. According to Sarkar, our relatively small number of known galaxies and the inability to know exactly how far apart they are leaves ample room to doubt and speculation. A concrete example is watching a single animal slow down in a large herd. It looks like all the others are running away from it at a fast pace. In the same perspective, it's possible that from Earth it only seems as though the universe is expanding at a given rate. And don't think that Sarkar is the first cosmologist to suggest that the current Big Bang models are inaccurate. Just 2 years ago, the New Scientist published several white papers showing that the expanding universe theory moves too fast to be compatible with accepted models of physics. And the following year, just in 2021, Alexia Lopez of the University of Central Lancashire discovered a giant line of galaxies that broke all sorts of rules regarding the Big Bang theory. The Big Bang predictions of CMB showed a smooth relic of initial radiation, but the observations show that only large scales demonstrate the predicted CMB levels. Overall, the Big Bang models don't allocate enough time for many regions to reach the equilibrium to receive the energy needed for measurements of CMB seen today. As a matter of fact, the most suitable solutions imply a curved universe, rather than the predictions of expansion for a flat universe. And with that, the predictions of density of dark matter are far greater than any measurements derived from the motion of galaxies. So, dark matter is necessary in the Big Bang theory, yet dark matter can't be quantified or even verified in the Big Bang theory. The Big Bang theory requires the existence of dark matter, but unfortunately, dark matter has been this mysterious particle that has actually never been observed in a laboratory. Despite the billions of dollars in extremely sensitive experimentation on Earth, the abundant observations of the motions of galaxies, and the massive mixture of dark matter in our sci-fi lexicon, dark matter particles have never actually been detected. In response, a growing number of cosmologists agree that the Big Bang theory calculations have been fundamentally misguided or even falsified. But data falsification is a discussion for another impactful video. For now, leave your thoughts down below regarding the evidence for and against the Big Bang. After hitting that like button, make sure you've subscribed to Space Infinity. Then head to the archive and watch more peculiar videos from Space Infinity.